This is Daniel Coosbury, and in this lecture we're going to look at applications of linear equations. In math, when you see word applications, we mean we're going to do word problems. So we're going to see how linear equations and solving linear equations can help us with real-life situations. So this is the strategy we're going to kind of lean on to do that. And these are just steps. You can kind of take them or leave them. But the first step is to read the problem carefully, and we're going to set x as any sort of variable or unknown, things that we don't know in the equation and the problem. So when we read problems, there's going to be something we don't know or something it asks us for. We're going to let that thing be x. There might be more than one thing, but we'll let that thing be x. And then step two is we're going to come up with expressions for any other unknown quantities in terms of x. So the idea in these problems in particular is we're only going to have one variable right now, and we might have other things we don't know that we can write in terms of that variable. So I'll kind of show you that as we do some examples. The third step is we're going to write an equation in terms of x that models it. So we're going to come up with a linear equation based on what the problem tells us about the situation. And then step four is the one that we should be comfortable with now that we've practiced solving linear equations. We're going to solve the equation that we made up from the problem, and then we're going to check the solution and make sure we've written our solution in a contextual way. So we don't just write like 7. We're going to say like whatever that number means. So let's look at some examples of not quite real world problems, but just some word problems that are going to get us practicing writing words as equations. So here's one. We have 2. When 2 times a number is decreased by 3, the result is 11. What is the number? So in this case, it's not, this isn't a real life situation, but we can still make an equation from this. We're asked what is the number. So this is the thing we don't know. We can call that x. That's x. Some thing we don't know. And we want to write an equation in terms of x so that we can find out what x is. So this says when 2 times a number, so 2 times a number, that makes me think of 2 times maybe x. So 2 times a number, that's what this is decreased by 3. So this word decreased here, usually that means subtraction. So we're going to decrease something by 3. I'm going to take 2x and subtract 3. There's that part, decreased by 3. The result is 11. So this is 11. Usually when you see is, it means it's an equal sign. When you take 2 times a number, you decrease it by 3, you end up with 11. So here's my equation I want to solve. Okay, I'm going to solve it real quick. For x, I'm going to add 3 to both sides, and I end up with 2x is equal to 14. Divide both sides by 2 to get x by itself, and I get x is equal to 7. So that number is 7. That's the answer to this question. Okay. B is a little bit different. B says when a number is decreased by 20% of itself, the result is 20. Oops, I lost that. So when a number is decreased by 20% of itself, the result is 20. So what I got to do is I got to say, okay, here's a number. I need to decrease it by something. So let's call that number x. Why not? And I want to decrease it by something. That something I want to decrease it by is 20% of itself. So you may have done this before. When we want to talk about 20% of a number, first we have to convert that 20% to a decimal. So 20% is equal to 0.2. We just move the decimal over 2 places. We get 0.2. 20% of a number is 0.2 times that number. Okay, so this is going to be 20% of itself, which is that number. 20% of x, or 0.2 times x. So now that I've written it, let me read it again. A number, x, is decreased by 20% of itself. So 0.2 times that will give you 20% of it. When I do that, the result is 20. So there's that word is again. That usually tells you there's an equal sign somewhere. So you take a number, decrease it by 20% of that same number, and you get 20. Yeah. I'm going to combine some like terms here. Here I have 1x, and I'm taking away 0.2x. This is the same thing as 0.8x. So 1 minus 0.2 is 0.8. So actually this is, that should be a 0. Actually this is saying that 0.8 times x is equal to 20. Or 80% of x is equal to 20. So taking away 20% of something gives you 80% of that. That kind of makes sense. And then I want to divide both sides times 0.8 to get x by itself. So that cancels. And then 20 divided by 0.8. Let me do that in my calculator real quick. gives me 25. So x is equal to 25. That number is 25. You decrease it by 20% of itself, and you end up with 20. All right, let's look at a real-world example now. So here we have the average yearly salary of an American whose final degree is a master's is $49,000 less than twice that of an American whose final degree is a bachelor's. Combined, the two people with each of these educational attainments earn $116,000. And we want to find the average yearly salary of Americans who with each of the final degrees. So here's what I'm going to do. I'm going to start by kind of talking about this first sentence and turning that into as an equation, and then I'm going to look at the second sentence and first. So here we first have the average yearly salary of an American whose final degree is a master's is $49,000 less than twice that of an American who has a bachelor's degree. So here's what I'm going to do. I'm going to take the salary of a bachelor's degree and maybe call that B. So the bachelor's is going to be B, and maybe the master's is going to be M. And at the end of the day, I might have an equation with one variable, but right now let's just call them different things. Okay, so this sentence says that the master's degree salary should be $49,000 less than twice that of the bachelor's. So I can represent twice of the bachelor's degree like this. Now that I've called it B, twice of the bachelor's salary could be 2B. And then 49,000 less than that, I'll ignore the 1,000 for now and just say 49 less than that is going to be this. So you got twice the bachelor's minus 49. That's 49 less than twice the bachelor's is equal to the salary of the master's degree. So if you know B, you can double it, take away 49, and you have M. So this is an equation that I can't really do much with, but I have another sentence here that's going to help me solve this problem. So this says combined, the two people with each of these educational attainments earn $116,000. So combined, the bachelor's salary and the master's salary are equal to $116,000. So combining them would be very similar to adding them. In fact, we can just say that B plus M is equal to 116, and we know that's in $1,000. We'll write that at the end. So if I add these two things together, I get this. Okay, so now what I want to do is I want to get an equation with only one variable in it. Right now I have two. I have a B and M in both. So how about we do this? Here we have M written in terms of B, where M is equal to 2B minus 49. Why don't we just replace M in the second equation with the B, and that'll give us an equation in terms of one variable. So the second equation can be written as B plus 2B minus 49. That's M. I just wrote it different. Is equal to 116. So now I have an equation I can solve. It just has b's in it. So I'll go ahead and combine the b's over here. B plus 2b is equal to 3b minus 49. It's equal to 116. Let's move that 49 over. Add it to both sides. I get, let me get my calculator. I get 116 plus 49, and I get 165 over here, and 3b over here. Divide both sides by 3, and I end up with B is equal to 55, and this is in $1,000. So now I know how much that the person with the bachelor degree makes. So the question asked, I should make sure I answer the question, find the average yearly salary of the Americans with each of these degrees. So I know what the guy with the bachelor degree makes. Now I should find out what the person with the master's degree makes. And I know that M is equal to 2B minus 49, and I know what B is. So I can plug in 55,000 for B. M is equal to 2 times B, which is 55, minus 49. This is equal to 110 minus 49. And let me do that real quick. And I get 61. And this is in $1,000. So notice how I've written my answer in a specific context. So the person with the bachelor's makes 55,000. The person with the master's makes 61,000 on average. Okay, let's look at another one. Okay, so in this one, in 2000, 31% of U.S. adults viewed a college education as essential for success. For the period 2000 through 2010, the percentage viewing a college education as essential for success increased on average by approximately 2.4 each year. If this trend continues, by which year will 67% of all American adults view a college education as essential for success. So in this case, it's not 100% clear what the variable is, but we do know that when you start out, you have 31% of adults who are viewing college as a success, and we want to know when you end up when 67% are going to view college as a success. We need to start by identifying what in this problem we don't know. So the question, sometimes that's in the question. The question says, by which year will 67 view college education as a success? So what it's asking is which year. So it'd be nice at the end of the day to say it's going to be after 5 years or 10 years. That's what we want to know. So that's going to be our variable, which year. Maybe I'll call that Y. That'll be the number of years until we get to that magic 67% of U.S. adults. So now that I know that Y is my variable, that's my years, I can actually think of an equation that starts out, well, if we start out with 31% of adults viewing college as a success, and each year we're going to add 2.4. So in the first year, we're going to add 2.4. In the second year, we're going to add 4.8. In the third year, we're going to add 7.2, and so on. All I'm doing is I'm multiplying. These are just multiples of 2.4. So in year 1, it's this. In year 2, it's 2 times that. In year 3, it's 3 times that. So what I'm going to do is I'm going to write this like this. Every year, I'm going to increase it times 2.4 y. Y is the number of years. So if y is 1, in 1 year, I'm adding 2.4. If y is 2, in 2 years, I'm going to add 2.4 times 2, or 4.8. And so on and so on. So that's kind of how that works. And eventually, I want to know when this is going to be equal to 67. So if I set up this equation right, when I solve for y, that should tell me how many years until I get 67% of adults in this viewing college as a success camp. So I'm going to treat this like a two-step equation. I'm going to subtract 31 from both sides, and I end up with 2.4y equal to 36. If I divide both sides by 2, I have 36 divided by 2.4 on the right-hand side, and that gives me y is equal to 15. 36 divided by 2.4. So this says in 15 years, then we'll have 67% of colleges view, 60% of people view college education as essential for success. So we can check our work if we wanted to. 31 plus 2.4 times y, 2.4 times 15. So this is 36 when y is 15. So 31 plus 36 gives me 67. So this works out well. All right, I got one more word problem in here. This is you're choosing between 2 health clubs. Club A offers membership fee of $40 plus a monthly fee of $25. Club B offers a membership fee of $15 plus a monthly fee of $30. And this says, after how many months will the total cost at each health club be the same, and what will the total cost for each health club be? So in this case, we want to identify the variable first. And in this first question, I see something very similar to the last example. This says how many months. So just kind of like how many years, how many months. We want to, at the end of the day, say how many months until those club memberships end up being equal. So this is our unknown, the months. Let's call that M. This is the number of months you're at the gym. So you're paying monthly. You're going to pay a certain amount every month. And now that we have that, maybe we can express some of this information in terms of number of months. So maybe, let's see, you start off in Club A with a flat fee of $40 and a monthly fee of $25. So this means every month you're going to be paying $25. So kind of like in the last example, in the first month you're paying $25. After 2 months you paid $50. After 3 months you paid $75. So what this looks like is is like in the last example, we're going to start out with a flat fee of $40 plus $25 for every month. So 25M. If it's been 1 month, you're going to do 25 times 1. If it's been 2 months, you'll do 25 times 2, which is 50, and so on. So that kind of represents your fee in this first one. So that's kind of how we'd calculate it. After 12 months, you do 25 times 12 and add 40, and that'll be how much you pay Club A. Now, Club B offers a membership fee for $15, so the flat rate is 15, and the monthly fee is 30. So each month you're going to pay $30. We can express this as 30 times M. So when M is 1, you're paying 15 plus 30. When M is 2, you're paying 15 plus 60, and so on and so on and so on. So in this case, the flat rate is represented as a constant. These are constants. And the monthly rate is the linear term. It's the coefficient times the variable. Now, this first question says, after how many months will the total cost at each club be the same? In other words, when is this cost going to be the same as this cost? We have a nice algebraic symbol to use to represent the same. It's called equal sign. When are those two things going to be equal? So now we have an equation. It's in terms of one variable, M, and we can solve for M. We'll do this by moving all the M's over to one side and all the constants over the other. So I'll start by subtracting 25 from both sides. It cancels out on the left, and 30 minus 25 gives me 5M on the right-hand side. Then I want to move the constants over to the left-hand side, so I'll subtract 15 from the left-hand side to get 25. It cancels out on the right-hand side, and I get 5M. Divide both sides here by 5, and I get 5 is equal to M. Now, what was M again? Oh, yeah, M was the number of months you're at either of these clubs. So after 5 months at each of these clubs, you're going to end up, their fees are going to be exactly the same after 5 months. And so that's really all we know. So the answer to the first question is going to be after 5 months, or we can say 5 months. If we wanted to write out with the units and all that, this is what our answer means after 5 months. The next question says, what will be the total cost for each club? In other words, after 5 months, how much will the clubs cost? Okay, so since we know it's 5 months and we have the cost of either club either here or here, we can just plug in 5 and see how much this costs. So let's go ahead and plug in 5 to this left equation. I have 40 plus 25 times 5, which is 40 plus 125, which is equal to $165. That's how much it costs at Club A after 5 months. Now, I've already done the algebra to show that the cost at Club A after 5 months should be exactly the same as the cost at Club B. But let me go ahead and plug in 5 here just to convince myself that I did everything right. So I'll just check the cost of Club B after 5 months. It's going to be 15, the flat cost, plus 30 times 5, which is 15 plus 150, which is also $165. So I've now answered both questions. I've said the cost is going to be $165, and they're going to be the same after 5 months. And I've also proven that they're going to be the same after 5 months by just plugging in 5 to both of those. So I had to use the algebra to get the 5, and then I was able to answer all these questions pretty well. All right, here's another problem. We have after 20% reduction, you purchase a television for $336. And the question asks, what is the television's price before the reduction? So what we don't know in this case is the price. What's the price before the reduction? So we can call the price P. And if we reduce price by 20% of that price, we end up with $336. So this ends up like a problem that we did a little while ago. If we reduce the price by 20% of that price, so the price minus 20% of that, we end up with $336. And the question is, what was the original price, which we already called P? So we'll just kind of work this out. We'll simplify this side. This ends up being 0.8P. I think we did one just like this. 336. Divide both sides by 0.8. I'll do 336 divided by 0.8. And I end up with P is equal to 420. So that was the original price. So these percentage ones may be a little weird to set up, but once you do a few, they kind of start feeling the same. The last thing we're going to do in this section is solving formulas for specific variables. So here's a formula. It's a volume formula, and we have the volume is equal to 1/3 times the base times the height, and we want to solve this for B. And all that means is we just want to manipulate this formula so that B ends up by itself. So I'm going to do that by moving everything that's not B over to the left-hand side. So for example, that should be an H. For example, I can divide both sides by H, and it cancels out, and I end up with V divided by H is equal to 1/3 B. So that's one thing I can do to move things over. And then if I want to get that 1/3 to go away, I can actually multiply both sides of the equation by 3, and the 3 cancels out with a 3 in the denominator, and I end up with 3v divided by h is equal to b. So all I did was use the addition and the multiplication properties to move things over properly so that b was by itself. So now if I have a volume of something and the height of it, then I can solve for the base if I wanted to. It's not going to be very hard. All right, here's one more. Here's E equals to mc squared, and I want to solve this one for m. This is mass. So all I got to do is move this c squared over to the other side. So if I have E equal to mc squared, I'll just divide this equation by c squared. I can do that, c squared. It cancels out over here, and I get E divided by c squared is equal to m. So that's how I would do that. So with the addition and multiplication properties, they're pretty powerful. They let us do a lot of things with algebra and solve a lot of really practical problems.